Let's go through the code 1307. Verbal arithmetic puzzle. So given an equation represented by words on the left side, and the result on the right side, you need to check if the equation is solvable under the following rules. So each character is decoded as one digit. This digit is from 0 to 9. And so those kind of character, they are also, there are at most 9 characters. You say that there are um, the number of different characters at most 10 characters. No two characters can map to the same digits. Each word I and the result are decoded as one number without leading zero. So for example, if S um, is the first digit, it cannot be for example, this kind of S cannot be zero. But there is some, this is not complete condition. For example, I have only a word like this. This, even that is the first digit, it still can be zero. So when we check if this character can be zero or not, we should check two conditions. If those kind of words length greater than 1, and this character is the first character, then this one cannot be 0. And the sum of the numbers on the left side would equal to the number on the right side result. So return true if the equation is solvable, otherwise return false. So that is where the question is asking for us that we have 10 different, at most 10 different characters. We want to map, for example, this kind of S map to some kind of digits from 0 to 9. So for example, if we map S to 9, E to 5, and N equals 6, D equals 7, M equals 1, and 0 equals, O equals 0, R equals 8, Y equals to 2. If we have this kind of map, we'll see this cent will be 9,567. This is 1,085. And then the result will equals this one, that is 10,652. So it is asking return true or false if we can find such a mapping that is solvable or not. Here we'll find the word length is small equal to 5. And also for the word's length at most for this kind of array, right? That is small equal to 5. And also every word, it has length smaller equal to 7. And also it says that those kind of character are at most 10, right? So this number is not that's not big. So for 10, right, even 10th exponential will be some of power 6, power 10 to the power 6 range, right? So we may think about even search brute forcely. We at least give us some kind of hint. We do some kind of DFS search for this question should still be doable, right? So what kind of things we should search? We can think about is that for these different characters, we search the mappings. For example, we find that there are 7 characters, right? Then we for every character we can search from 0 to 9, right? And if this used, then second one we can use something else, right? We just search the mappings. So how can we write the code? What will be those kind of termination conditions? For this one, we'll see it is trying to change this kind of words into a number. For example, and send, right? So we know this S is in a thousand digits, right? So no matter this is what kind of digit is mapping, we can say this S, for example, if we map to 2, right? So on the left, we'll have S multiplied by 1000, right? So that will, the sum will be always be, for example, if it's 2, it will add 2000, right? So we can use some kind of weight, character weight um, map, right? So that means that, for example, we have cents here. Another one is, for example, S, right? So this kind of here, S has 1000 weights, and here S has 1 weights, right? So this is a words list. And for example, we have a uh, um, uh, cos, right? This is also 1, right? And 1, and um, so we'll say for this S, if we have this kind of words, right? So we'll say this S is going to have 1000 plus 2 in this kind of list, right? So let's take some other example. For example, this S, right? It appears in the 100 digits, appears in the 10,000 digits, right? And also 10,000 digits. So that one, this S will say it will be 2 multiplied by S in the 10,000 digits, right? And also, this is a 100 one, right? So that means we can have a weight. For example, we just for this S, we have something called which record have a map which is 2001, right? 100 for this kind of character, because no matter this how many what number this S is mapped. For example, this will be in map 9, right? So our sum just multiply by 9. If this is map to 7, we just our sum will map to 7, right? And also let's look at another one, right? Like E, right? So let's see, this E appears in the 1000 digits, appears twice, so that is 2000. And also it appears in the 10th digits, right? So this, we'll say this E has a weight 2020. So so this gives us some kind of easy way we can think about it. So for every character, we use a character to integer map to store its weights. And we when we do the pre-processing, we have something to create this kind of map, right? And how do we? The total sum will be easy, right? So that will be for every digits. Um, if we, for example, we in our DFS this kind of character for every character, if we map to our digits, right? For example, map to 7, then the sum will contribute to 7 multiplied by this character's weights. So we pre-processing a map which is a character to weight to integer weights. And the things that we do have DFS, we can have a sum, right? But for the results, that is another mapping, right? So how can we check if the sum equals this result? Actually, we can have another trick here, is that we have this result to be negative negative number and put that into the words. So that means I have words that is send, right? Send um, more and negative money. So so our so what we do is that we can have a weight, right? So for the money, we have this is in the 10,000 digits m, right? So let's look at where does m appears. This is 1,000 digits. This is 10,000 digits. So we have a negative money here, right? So let's say so the m, we'll see its weight is negative 9,000. Right. So our DFS is that we just trying to get the sum, right? And trying to find if it is equals to zero, right? Because we just treat the result as a negative weights to our um negative words, right? And all of the weights will be a negative one. Um, if the sum equals zero, then we return true. How can we handle the leading zero, right? So we can also go through all of these kind of words. If the length is greater than one, right, we use a set. Um, we use a set to we can call leadings or blocks, right? That means for those characters, for example, S, right, we cannot be zero, M cannot be zero. So when we do the DFS trying to the mapping those kind of list to a list of character to digits, we check the character first, right? So let's write code for this. Um, we are going to have a map. So character and integer, let's call it weights equals new hash map. And we're going to have a set, which is called the leading zero. So that every character in this kind of set, we cannot set we cannot iterate set DFS. We cannot set this one into zero, right? It's called leadings. Then we do processing for the words and results, right? We need to process twice. Um, we can write a help function to process it, private void process, right? Process. So we need this kind of weights map, and also we need this kind of leading character. And we need a string word, right? So what we do is that, for example, we have char array equals word. Um, mm, and for this one, actually, we need a flag, right? Because for the we want to reuse this one. For the result, this kind of weight will be a negative one, right? So we can have a hint, right? Flag. So for these words, this flag will always be one, and the result we use a negative one, right? So we do this one equals this kind of length. So word to char array, sorry, to char array, and we're going to have int n equals array dot length. Here, we say this weights, right? We'll say because the length is smaller equal to 7, right? And and also you'll see the word length is small equal to 5, right? So this kind of 10 to the power 7 and multiply by 5. So the worst case when it will not and even that is 9, right? Or multiply by 10 again, it will not exceed those kind of integer maximum. So we use this kind of integer to store this weight is enough. So we have, for example, base equals to 1, right? So what we do is that for int I equals n minus 1, I greater equal to 0, I minus, right? Then what we do is weights merge array I. So it will be, for example, flag, because this will be negative for the result, right? Flag multiply base, and it will integer dot sum, right? So every time, so we'll say so base equal, so that base multiple by equal to 10, right? So that means for this one, test the weight 1, right? For every digits, and here we'll have weight 10, and here will be weight 100, right? Um, and if it is a result, right? If it is a result, we call this, we use a negative one because we have a flag, right? Use a flag too. So how can we, so um, this one handle the weights map, and we also need to try to see the leadings, right? So we will say if this kind of n is greater than 1, right? So let's say only length is greater than 1 and the first character. So don't forget this kind of line. This is easy to forget, right? So only when this one we're going to have leadings at array 0, right? So for this kind of leading is that when we do DFS, we are going to have a blocking criteria, right? So here, we processing is that for string word in words, then process weights, leadings in the word, and this one will add, right? And for the last result, we need to process weight, leadings, and result. And this one will be -1, right? So this is processing to have every character in the words and the results to map to a weight, and also find those kind of leading characters. When we DFS, we may block them, right? So then we know we for map those keys will be all of the characters appears in words and the results, right? So we can have a list of character we call chars equals new array list weights, dot key set, right? Um, then so we know this kind of we have for every character it has some kind of weights. It can be, for example, 9,000 to 28 negative 100 and 21, right? Or those kind of values. Negative can only be it's not necessary be one, right? Because the result it may have multiple. So and and so every character it have a mapping, right? So what we do is that we sort we try to see if this kind of sum when we DFS, for example, if this one map to 2, right? This one multiplied by 2, and this one multiplied by 3, right? For example, when we DFS. So for our DFS is that we can do another optimizations is that for those kind of weights which have absolute values which is greater, right? And if for example when we calculate to our index um because all of these kind of weights um is absolute value is in the we thought those weights are decreasing order, right? So all of the weights is greater equal to these weights. So for example, this kind of if we have this sum is greater than for example n minus I um minus 1, right? That is the rest multiplied by weights. So the rest that means those kind of sum will never um be be zero, right? Because if the greater one, if already because on the here, the absolute value of the weights will always be greater than absolute weight of zero, right? So of course we can also multiply by 9 for each digits, right? So that's the worst case. If already the current sum greater than this kind of number and assume those kind of weights, we use a maximal current one, right? Then we can terminate. So we can sort this character in a descending order, have another termination conditions here, right? So let's write this logic as well. So we can have collections, sort, chars, and A, B, right? So let's sort by its weights in ascending order, right? So the weights, because there is negative and positive values, so we need absolute values, right? So that's why be mass dot abs weights gate b and mass dot abs weights gate a, right? So in this case, we'll have always have a heavy weights on the left, right? So the weights we only consider its absolute value. And we're going to have when we DFS, right? So we know this kind of digits we need to, this is like a permutation. So for every character, we have options to use from 1 to 9, 0 to 9, right? And so for permutations, right, we need a Boolean use array. So that will be new Boolean, right? So for our DFS, we return let's return have a DFS return a Boolean result. Of course, sometimes some people don't use that, don't like this, can have a Boolean result array, right? And have a void, right? So for this one, we just return DFS and chars weights and used leadings, right? And our index. Um, so this index, we are going to iterate in this charts array, right? So that will be we trying to see in this chart already trying to map it for every character mapped from 0 to 9, right? And also we need a sum, right? So the termination condition is this sum well equals to when for example index equals n and sum equals 0, right? Then return true. So that will be these parameters will be enough. So let's write the DFS. So this is the character. So we need a chart and also map um, character, integer, need a weight, and we need Boolean used because this is like a permutation. Um, and also we need a leading one, right? So when we do permutation, we need to check this kind of set. Um, or leadings, and also the index in the charts list, and also the sum, right? So this will be our DFS part. And so we'll say let's get int n equals charts dot size, right? So what we do is that if ID equals n, right? So what we need to return is return this sum equals 0. So treat this result as a negative word in this word list, right? So get things simpler. Otherwise, you need to you find the sum and trying to also need to have some way um to to calculate the result sum. That will be get things complicated. So what we do is that we have character C equals this chart get ID, right? And int weight equals weight get C, right? So then we try to let this character to map every digits, right? So what we do is that for int d equals 0, d smaller equal to 9, d plus plus, right? And if used d, we should continue. Also, we need to check if for example index um, if d right equals to 0 and also this character is in a leading set, right? Then we should also continue. That means leading character we cannot set it as 0, right? So if d equals 0 and leadings contains c, we should also continue. Then um we are going to have, for example, let's write early terminations here, right? So the new sum equals sum plus d multiplied by weight. So we'll say here we can write a condition if mass dot absolute value, new sum is already greater equal to the rest number of character, that is n minus 1 minus id, right? So that is from ID plus 1 to n minus 1, right? So it will be n minus 1 minus ID minus 1 plus 1, right? So that is minus 1 minus ID. And we'll see the rest part, the weights, right, will always smaller equals to current weights for the absolute value, right? So let's say if this one multiplied by mass dot absolute value weights, right? So this will be extreme case. And also for the rest part, if the worst case is every character is set as 9, right? Um, but so this is a kind of extreme case. Then we can early terminate. Should continue, right? So this we use this thought to have our DFS to be can trim branches early, right? So then we can just for every possible D, we use the D equals to true, right? And use the D equals false. So here we have DFS child, right? So this one need to return, right? So that is if DFS chars weights use leadings. So we look at the next character, new sum, right? If this one, every one of this DFS is true, we just return true, right? So if for every, we didn't find any true, right? We just return false. So this will be the DFS part for this question. Uh, not many symbols. Okay. We can also write a Python code for this. Should be very similar. We need a dictionary, right? From collections, import default big. So we need weights and leadings, right? Leadings. Weights will be default big int, and the leading will be a set. So what we do is for every word in words, right? Hmm, we can have a process. We need this kind of weight and leadings, and also need a word, and also need a flag, right? So we can define process weights. We don't need weights. Actually, we just need a parsing word and one, right? It has um, so word flag, right? Then what we do is uh, base equals 1 for I in range uh, length. word minus one, right? And minus one, minus one. Um, we are going to have weight word, right? With a plus equal to base, right? And also base should multiple equal to 10. So also we need, so this is handle the weights map. And also we need to check the leading zeros. If length word is greater than one, right? We have leadings. So this will be flag multiple by weight, right? Because for the result, we are going to have a negative one. Leadings will add word zero. Okay, so this will be process, right? And in our main function, um, we need to also process those kind of last the result, right? So result, we need also process result, but this one we treat as a negative weight. Okay. And also, so after doing this, um, we can get with keys, right? So we call chars equals sorted weight dot keys. So we sort by key. This equals lambda lam c should be absolute value with c, right? And we should be reversed because we want to have the greater weight to be due earlier, right? Because so that we can terminate early. Because when we calculate the smallest small part, right, we cannot terminate. But for the greater part, if all of that we can calculate, for example, some kind of values, and then the later part will never achieve this kind of absolute value. That means we can terminate early, right? Then what we do is we use the equals false, which are multiplied by 10, right? Because the permutation return uh BFS chars weights use leadings zero zero, right? So we can also define our DFS here. For example, chars that is unleased and weights is undict and used, which is unleased leadings that will be a set. I dex index will be an int. And total, right? Let's use total instead of sum. Sum is the preserved word. And let's let this one return word. So if index equals the length of chars, so what we need is return this kind of total equals zero, right? Then we get C equals chars index and weight equals weight C. And then for D in range 10, right? We insert D possible values. If used D, we should continue. Also, if D equals zero and C in leadings, we should also continue, right? And then we are going to have a variable called new total equals total multiplied by D plus D multiplied by weight. So what we will say, if absolute value, right, new total already greater than um length of charts minus one minus index and then multiple by 9 multiply weight, right? Absolute value, absolute weight, because it may be negative. Then we can terminate, continue. And then we do backtracking. Used D equals true. Um, used D equals false, right? So what we do is that if DFS charts with used leadings index plus one, right? And new total. If this one return true, then we return true. And our DFS need to have a return result that will be return false. So this will be our Python code. So in range length word, I for I, right? So this is I. So this will be the DFS for this question. We use weight map to do some kind of trick for these questions, right? And also we treat the result special weight, that is a negative weight, right? The word in the word list, they have positive one uh, for every character, and also we have flag, right? That is a negative weight, but for every character appears in the digits, one digits will have weight plus one, and on the 10th digit will have this one has a weights plus 10, right? So we have total weights. So in the result, for example, this will be minus 10, right? And for this E will plus one, and this R will plus 10, right? This S will plus 1,000, right? And this M will plus 1,000. This M will minus 10,000. And also we check the termination condition is the sum equals to zero. So doing like this, let's consider those kind of time and space complexity, right? So we know there is a thought here, right? This thought is actually not a big deal because the character can at most be 10, right? So even for example, there are U counts unique characters log U, right? So that will be a very small number. Even for example, there are 7 log 7, right? So this part we don't need to worry. And also this they are linear, right? So that is U, right? Unique number of characters. But the most time consuming part is the DFS part, right? So for every character, we have a optional to be 0 to 9, right? Then we use the one, then will be 0 to 8, right? So this will be let me say So that will be a factorial, right? 10 factorial. Uh, the worst case if we don't consider the early terminations. So this DFS will be 10 to the factorial time complexity. That is the most time consuming part. And so we'll say the total one, right, will be 10 to the factorial time complexity. And space, right, those kind of data structure are all linear, and there are only U types of records, U counts of records with setting a map or set. So we can consider this or like a linear U space complexity.